In this video, I want to do another splitting field problem. And this time I want to find the degree of the splitting field of x to the fourth plus 2. Over q. Okay, so as before, the first thing that we want to do is we want to find the roots of this polynomial. This is slightly complicated because the roots of this polynomial are going to be any complex number that if we raise it to the fourth power, it gives us -2. So we're going to need a fourth root of 2. Okay, but we need to multiply this by something that if we raise it to the fourth power, we get -1. Okay, so one number that would work is e to the I pi over 4. So let's check this, right? So if we do fourth root of 2 e to the I pi over 4, and then we raise this to the fourth power. So this is going to give me fourth root of 2 to the fourth is just 2. And then e to the I pi over 4 to the fourth power is just e to the I pi. And then this is -2. Okay, so that works. Okay, so this is one of my roots. The other roots are going to be fourth root of 2 times all of the other complex numbers that if I raise them to the fourth power, I just get -1. Okay, so that's going to be e to the I 3 pi over 4. That one should work. Fourth root of 2 e to the I 5 pi over 4. And then the last one is going to be fourth root of 2 e to the I 7 pi over 4. Okay? So these are my roots. So the question is, what is the splitting field? So what's the minimal possible field that contains all of these roots? Well, notice that if I have e to the I pi over 4 in my field, then I'll definitely have e to the I 3 pi over 4, e to the I 5 pi over 4, e to the I 7 pi over 4. So I'll have all of those. So I really just need to find the smallest extension of q that has e to the I pi over 4, and then that also has fourth root of 2. So I'm going to claim that that field is q adjoin fourth root of 2, I. So let's check that this contains all of the roots. Well, it definitely has fourth root of 2, but because fourth root of 2, so fourth root of 2 is an element of this, but then that also means that square root of 2 is an element of this, because this is fourth root of 2 squared. Okay, so because I have square root of 2, I also have square root of 2 over 2, which means I also have root 2 over 2 plus root 2 over 2i. Okay, and this is equal to e to the I pi over 4. Okay, so this is definitely my splitting field right here. So let's box it in. And then the question is, what is the degree of this over q? So let's do this in a different color here. So let's notice that, another way to express this extension is that this is q adjoin fourth root of 2 adjoin I, right? So we want to do the same trick, that we want to think about what is the extension of q adjoin fourth root of 2 over q. What is the degree of that extension? And then if we then have the extension q adjoin fourth root of 2 adjoin I, what's the degree of that extension over Q adjoin 4th root of 2? So this first extension is pretty easy, because what's the minimal polynomial of 4th root of 2? Well, it is x to the 4th minus 2, right? This is irreducible by Eisenstein's criterion. Okay? And the degree of this polynomial is 4, so that means that the degree of this field extension is equal to 4. Cool. So then we want to notice that this field, so Q adjoin 4th root of 2, this doesn't contain any purely complex numbers. So looking at this extension, Q adjoin 4th root of 2 adjoin I know that I is a root of the polynomial x squared plus 1. Okay? And this is a polynomial that only has complex roots. So if I'm dealing with a field like this one, Q adjoin 4th root of 2, that doesn't have any purely complex numbers in it, then this polynomial must be irreducible over that field. Right? So that means that this is the minimal polynomial of I over Q adjoin 4th root of 2. So that means that the degree of this extension is the degree of this minimal polynomial, which is 2. Okay, so finally, this tells me that the degree of my extension is just going to be, well, it's just going to be the product of these two degrees. So that tells me that the degree of this extension is equal to 8. And yeah, that's it. Thank you very much for watching.